Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Social Sciences, SOSS, Postgraduate Diploma in Disaster Risk Reduction and Management, PGDDRRM, MPA031 Physical Geography, Block-1 Geomorphic Processes, Unit-4 Exogenetic Processes, 4.0 Objectives. After studying this unit, you should be able to define weathering, explain its process and types, describe and classify mass wasting, elucidate the processes of weathering and mass wasting, and describe the concept of cycle of erosion explained by W. M. Davis and W. Penck. 4.1 Introduction. In Unit 3 of this block, you have studied about endogenetic forces that operate from within the Earth's surface. They are responsible for upliftment and subsidence of areas. They also the cause of folding, faulting, earthquakes, volcanic eruptions, etc. In this unit, you will learn about exogenetic processes, or forces which originate from the Earth's surface and atmosphere. They are associated with reduction of elevated areas. The imprints of exogenetic processes are visible on the Earth's surface. Primarily, there are three basic types of exogenetic processes, namely weathering, mass wasting and erosion, occurs. All of them operate on the Earth's surface. In Sec 4.2, you will learn about the factors controlling weathering, mass wasting and their types. Sec 4.3 explains you about the concept of cycle of erosion. You will also study about the theories of landform development propounded by William Morris Davis and Walter Penck. Erosion is the movement of weathered available material. It is primarily performed by the various geomorphic agents like river, karst, glacier, wind, and sea waves. They are explained in Unit 5 and 6. Now you will study the process of weathering and mass wasting and the concept of cycle of erosion. In this unit, 4.2 Weathering and mass wasting. Have you ever observed the local topographical features of your surroundings? For example, physical features like mountains, valleys, plains, rivers, deserts, coasts, etc. are getting changed over time. In fact, centuries back people thought that mountains, deserts and lakes, etc. are unchanging. They will always be there as they are visible today. Advanced scientific experiments discovered that the Earth has been evolved 4.6 billion years ago. Now, it is a proven fact that Earth's features are continually changing due to exogenetic processes of weathering, mass wasting and erosion. Exogenetic forces are also called land wearing and tearing forces. Most of the exogenetic processes are very slow, but some of them like torrential rain and flowing water along steep slope or excessively high sea waves, especially during tsunami alters the affected areas very strongly. You now know that the endogenetic forces elevate the land, while opposing exogenetic processes continually wear and tear it down. Exogenic forces are called as denudational or destructional processes. Originated. They are originating from the Earth's surface or from the under the influence of gravity. Various exogenetic geomorphic agents such as running water, groundwater, glaciers, wind and sea waves remove the disintegrated rock materials. Removed materials are transported by those agents. When the transporting ability is reduced, those materials are deposited. These processes are continuously engaged in sculpturing the area. It is termed as denudation or degradation. In this section, we will focus on the process of weathering and mass wasting. Let us now discuss about the process of weathering. Weathering is a process in which the surface is worn and teared in situ without substantial transport of the broken rocks. Rocks are continuously under the process of disintegration or decomposition of rock. It means long-distance transportation is not involved. If at all the transport is visible, it is found under the influence of gravity. Due to gravitation of the Earth, the fragmented rocks on the slope could not retain their, hence, they come down. Scientific definition of weathering involves mechanical fracturing or chemical decomposition of rocks by natural agents at surface of the Earth. Weathering process can be grouped into three categories. They are I. Physical or mechanical weathering, 2. Chemical weathering, and 3. Biological weathering. Before discussing about the types of weathering, you shall know the important factors that affect the weathering process. Factors controlling weathering. Weathering plays a major role in denudation process. The nature and intensity of weathering vary from place to place and from region to region depending upon various factors. There are mainly four important factors affecting weathering. They are A. Structure and composition of rocks, B. Climate, C. Topography, and D. Vegetation. Rock structure includes rock's massiveness, porosity, permeability, joint patterns, bedding planes, faults, fractures, etc. The mineral composition of rock involves chemical characteristics, grain size, crystallinity, etc. of the rocks. They largely affect the nature and intensity of weathering. The minerals forming the rock determine whether rock is more susceptible to chemical or physical weathering. Rocks rich in carbonates are susceptible to chemical reaction. Hence, they weathered very easily in comparison to non-carbonate containing rocks. Rocks with numerous joints allow the entry of water, air, and roots of the trees, etc., and are more subjected to mechanical disintegration. Horizontal, bedded rocks are affected by the mechanism of disintegration and decomposition, whereas vertical strata are broken down due to frost action and ice. There are several components under climate which affect weathering, but temperature and humidity are very important. There are several types of climatic regions. Each climatic type produces certain types of weathering. High temperature and moisture cause greater leaching and hence, weathering is more. Big range of temperature, diurnal or annual, causes expansion and contraction of top layer of rocks which lead to more breakage and disintegration. Temperature fluctuations above and below freezing point leads to freezing and thawing. They cause mechanical weathering of rocks as well. Chemical weathering is the highest in humid tropical areas. Topographical factors include elevation, slope, and aspect. They also influence the rock exposure responsible for weathering. Weathering is more on higher slope because weathered materials are removed downward under the influence of gravity. Since the surface is exposed, more weather is caused. The presence or absence of natural vegetation in a particular region affects weathering. Vegetation covers and protects the rock outcrops from the direct impact of sun rays, but at the same time the roots penetration breaks down the rocks. It leads to the disintegration of rocks. Now, we will study the types of weathering. Primarily, weathering is of three types: A. Physical or mechanical, B. Chemical, and C. Biological. 4.2.1 Physical or mechanical weathering. Physical or mechanical weathering is the breakdown of surface rocks into smaller fragments ranging in size from large blocks or boulders to fine sand and silt. It involves mechanical disintegration of rocks without any change in its chemical composition. In the process of disintegration of bigger rocks into smaller pieces, the surface area keeps on increasing. Larger exposure of areas to nature over which weathering is taking place. Weathering is enhanced depending upon nature of climatic conditions and rocks. Mechanical weathering is performed in several ways, namely frost action, salt crystal, growth, thermal expansion and contraction, and the mechanical action of plants and animals. Disintegration of rocks can very well be understood by the illustration given in Fig. 4.1. It begins with the formation of cracks in bedrock. When cracks widen and deepen, the rock becomes susceptible to disintegration. Those cracks are called joint lines. They may extend for several meters into the bedrock. In this process, rocks are weak and subject to more wear and tear. Look at the screen, Fig. 4.1. Mechanical disintegration of rocks, intersecting joint lines leading to the formation of blocks and smaller particles that are subsequently eroded away. Frost action or ice wedging is one of the most effective types of mechanical weathering. Water in the rock periodically freezes and thaws during night and day in those areas where the temperature fluctuates around freezing point. The water entered into the joints freezes and forms ice, which causes the joints deepening and widening. When the ice thaws, the water flows further deep into the rock. Generally, when water freezes, it increases about 9% in volume. This repeated expansion activity of water can cause pressure in rock pores, cracks and crevices leading to the disintegration of rocks. This process is found to be most effective in well-bedded or jointed rocks and very common in cold climates, -5 degrees to -15 degrees Celsius. Fig. 4.2 shows the effect of frost action. Salt crystal growth is caused by the crystallization of salts from evaporating water. In arid regions, dry weather draws moisture to surface through rock openings by capillary action of water, which may contain salts. As the water evaporates, the salts are left behind as tiny crystals. These crystals expand as they heat up or dry and exert a force or enough pressure towards breaking up the rocks. Thermal stress weathering results from the expansion and contraction of rock, which is caused by rapid temperature changes. This type of weathering is mostly found in desert regions where there is high temperature in the day and cool in the night. In the hot desert areas, the outer layers of the rock expand from heat in the day and contract from rapid cooling during the night. Differential expansion and contraction due to diurnal range of temperature causes the tension and stresses leading to the formation of parallel joints in the rocks. This process is termed as exfoliation. In this process, rock layers start peeling off in sheets or slabs. Fig. 4.3. Look at the screen. Fig. 4.2. Frost action. A. Water seeps into cracks. B. Water freezes to ice. And C. Breaks the rock. 4.2.2 Chemical weathering. Chemical weathering is the breakdown of rocks by the alteration of rock-forming minerals. Chemical alteration of minerals involves many types of reactions between the atmospheric and biotic agents. Some minerals, e.g. olivine and augite, occur in basalt, are far more alterable than others, like quartz. Quartz is extremely resistant to chemical change and slightly soluble in water and more in saline water. It is known that many minerals soluble in rainwater are usually acidic in nature and leach rocks quite actively. Chemical weathering is most effective in warm and humid climates compared to cold and dry regions where heat and moisture are in abundance. Chemical weathering involves a number of processes. All are associated with moisture. When water comes in contact with chemically reactive rocks along with atmospheric carbon dioxide and oxygen, rocks get disintegrated. Most significant among the processes of chemical weathering are carbonation, hydrolysis, and oxidation. Carbonation is a chemical weathering effective on the rock which has calcium carbonate, CaCO3. When atmospheric carbon dioxide and water come in contact with calcium carbonate containing rocks, it forms carbonic acid, H2CO3. Carbonic acid dissolves or breaks down minerals in the rocks to form calcium bicarbonate. Calcium bicarbonate is soluble in water and thus weathering is resulted. This process dissolves the rocks over a long period of time and creates numerous landforms. In nutshell, it is like CO2H2O H2CO3, carbon dioxide water carbonic acid. CaCO3 H2CO3 Ca2 to HCO3, calcite carbonic acid calcium bicarbonate. Hydrolysis is a process in which chemical combination of water with mineral is involved. It produces a new mineral compound which is weaker and soft mineral. It results into disruption of the rock. For example, silicate minerals like potassium feldspar present in many igneous rocks are weathered and a clay mineral, kaolinite, is formed that is susceptible to disintegration. Most of the minerals, except highly resistant mineral like quartz, are very susceptible to chemical change when exposed to atmospheric and biotic agents. Hydrolysis is mostly observable in weathering of granite and igneous rocks that alters the minerals irreversibly. You may observe many of the rusting metals in your home locality. What do you think of the causes behind it? You might have also observed the rusting in old blades or iron knife forks, window frame, nail, agricultural implements, etc. These are very common examples around us. This is an example of oxidation process commonly occurring in the natural environment, especially with iron-containing objects. Hence, oxidation is a process in which the dissolved oxygen in water comes into contact with certain rock minerals, especially iron, to form oxides. Oxidation generally accompanies hydrolysis and is the most apparent in rocks containing iron. When oxygen combines with iron, the reddish iron blisters are formed, which is the most common oxidation effect in the rocks. This process is known as rusting and is responsible for an initial indication of chemical weathering in many rocks due to their discoloration as brownish red to red. When the iron is oxidized, it forms ferric iron, which in turn is transformed into limonite. Limonite is a mineral that resembles with rust 4.2.3 biological weathering, the loss of minerals and ions due to animals and microorganisms' actions as well as growth of plant kingdom is termed as biological weathering. Biological weathering is also known as organic weathering. It is the weakening and disintegration of rock by microbes, plants and animals including human beings. Growth of plant roots inside the cracks, joints or fractures and faults produces physical pressure on the rocks. The stress build-up on the rocks is a part of the biological process. Growing roots, actions of technologically advanced human beings are, nowadays, very effective in making the land surface exposed for weathering. Wedging and burrowing of rocks are common by rodents, earthworms, termites, rabbits, etc. Mosses, algae, bacteria, lichens, etc. grow on the rocks, especially in warm and humid areas. All of them are responsible for weakening the rocks and help in weathering. 4.2.3 Mass wasting. You now know the process of weathering in which the massive bedrock breaks up. The broken blocks of rocks are fragmented and unconsolidated on the slope. The fragmented and unconsolidated rocks have a tendency to move down slope. Hence, weathered material is moved relatively for a short distance down the slopes under the influence of gravity with or without the assistance of running water. It is called mass wasting or mass movement. There are several factors favoring mass wasting. They are structure, closely spaced joints, faults, etc., composition and permeability of rocks, topography, steep slopes and cliffs, climatic factors, large variations in temperature, heavy rainfall, etc., vegetation cover. They are important factors of mass wasting. The large amount of debris of mass movement can sometimes be able to bury a town or village on the mountain slope. Young mountains with fragile slope are examples of mass wasting. When pores in the sediment are filled with water, they cause the materials slide past one another due to loss of binding effect of the sediment particles. Normally, addition of water in the rocks through rainfall and snow melt along the slope lubricates the contact surface. It results into several forms of mass wasting due to earthquakes and aftershocks. Particularly faulted and jointed bed rocks can be dislodged move downslope. Mainly, there are three basic classes of mass movement such as falls, slides and flows. Fig. 4.5 Look at the screen. Fig. 4.5 Types of mass movement. Gravity is a natural force which attracts every object towards the center of the earth. Isaac Newton, renowned physicist, first proposed universal gravitation law in 1920. He said that all objects in the universe attract every other object. This attractional force is known as gravitational force. Falls refer to the free falling of pieces of rock from any steep slope. In this process, the rock blocks or fragments are dislodged from a cliff or steep slope and fall, roll or bounce down to the cliff foot. These falls mostly occur in the mountainous region due to frost action and other weathering processes. The resultant broken rock material accumulates at the foot slope, forming steep ramp-like incline and are collectively referred to as talus or scree. Slides occur when the large masses of rock as a unit or block moves downslope abruptly. In this type of mass wasting, rock or soil material slips downhill. It is called slope failure. Landslides are the most significant type of mass wasting. It is an instantaneous collapse of slope. It happens due to lubricating effect of water and sometimes it happens without water availability as well. Flows. The most common slower flow type of mass movement is creep or soil creep. It is the slowest and imperceptible downhill movement of debris and soil is described. The mechanism involves freeze-thaw and wet-dry conditions contributing to soil creep by progressively moving soil particles down the hill. The rate of creep is very slow. We may observe the evidence of this process in the field through downward curvature of trees, tilt of fencing posts, electric and telephone poles, and inclined structures on creeping slopes, etc. Some flows are characteristically rapid movement and occur when the soil mass is being saturated with water. The most common types of flow movements are earth flow and mud flow. The rapid movement of water-saturated soil material flows down on relatively low-angle terraces or hill sides is known as earth flow. At the top hill slope, a steep scarp is developed where the moving debris is pulled away. The flow effect is very clear in the lower portion, where a toe of material pushes out over the valley floor. On the other hand, a mud flow is a mass of supersaturated rock particles of all sizes soaked with sudden heavy rainfall and or shallow groundwater. The runoff waters carry the soil and rock debris from a large steep sloped area. Thus, water and debris move down slope very quickly. Till now, in this section, you have learnt to basic external processes occurring on the Earth's surface. They are weathering and mass wasting. Now, you it very well that how weathering and mass wasting are taking place as well as their controlling factors. In the following section, you will learn about the concept of cycle of erosion. And views of Davis and Penck in this regard. 4.3 Concept of Cycle of Erosion. You have studied about endogenetic forces in Unit 3 through various types of relief features are produced on the Earth's surface. Exogenetic processes are operating on the relief and are trying to eliminate the differences created by the endogenetic forces. They are trying to bring the surface to the sea level or base level. Erosion is a process in which various erosive agents remove rock, debris and transport them and deposit them where its ability is reduced. It leads to lower the elevated landmass and ultimately supposed to reach to the base level from where the landmass had evolved. Hence, evolution of landmass from sea level, its rise above and finally reduction of the same to the base level is called. The concept of the cycle of erosion or geographic cycle was initially proposed by an American geomorphologist William Morris Davis in 1899. The main concept of Davis explains the developments of landforms in a sequential order of a cycle. Apart from Davis' concept, some other concepts on cycle of erosion were proposed. Some of them are W.M. Davis, 1899, W. Penck, 1924, K. K. Markov, 1948, L. C. King, 1962, I. P. Gerasimov and J. Meserjakov, 1970. For discussion, only two concepts by Davis and Penck are discussed below. 4.3.1 Davis Model. The geographical cycle of W. M. Davis was the first modern theory of continental erosion and landscape evolution. He postulated the cycle as a period of time during which an uplifted landmass undergoes its transformation by the process of land sculpture turning into low featureless peneplain. He assumed that the initial form of landmass got uplifted from beneath the sea by earth movements. He emphasized that the upliftment phase of land mass is very short. Once the landmass is uplifted, denudational function would start. Davis is criticized for this statement as exogenetic forces would not wait for the upliftment to be completed. According to Davis, the landscape is a function of structure, process, and stage. All of these three play a dominant role in the origin and development of landforms over elevated landmass. Structure deals with the nature of rock, whether hard or soft, as well as its characteristics like folds, faults, joints, layers, etc. Over a landmass with softer rocks, cycle is completed in a shorter duration compared to the hard rocks. Process is concerned with internal and external forces that shape the landscape. Stage means time duration within which the processes are at work. Land sculpture varies in different stages. When landmass is uplifted, the erosional agents start working on it to convert featureless surface. Davis envisioned a continuous sequence of terrain evolution which is linked to the life cycle of organism defining as youth, mature, and old stages. Fig. 4.6 explains the three basic stages of cycle of erosion. Look at the screen. Fig. 4.6 Diagrammatic representation of the vision cycle of erosion. Youthful stage. The process of denudation is initiated by the exogenetic forces with the upliftment of landmass by endogenetic forces above the sea level. In humid, climatic environment, because of sufficient rain, a system of streams normally develops on the emerged landmass. The top surfaces or summits of emerged landmass are literally unaffected by fluvial erosion. Streams erode its valley as water flows with concentration. The streams with incised deep, steep-sided, narrow, V-shaped valleys with irregular gradients marked by waterfalls and rapids. In this stage, shallow lakes and swamps can be found. According to Davis, youthful stage is described as an area of younger and juvenile stage of river valley development maturity. The early stage of maturity indicates lateral erosion and well-integrated drainage system. The falls and rapids are worn away and thus the area would develop smooth profiles. The main river and its tributaries are graded to the base level of erosion. The stream will consume less amount of energy to move its load. It results in the reduction of valley deepening due to the substantial decrease in channel gradient and flow velocity. Because of the lateral erosion, V-shaped valleys of youthful stage are replaced into broad and wide valleys and floodplains are formed. By the end of mature stage, relief is reduced rapidly and valley floors are graded. Old stage, this stage is characterized by the gradual reduction of river gradients and associated decline of stream energy, absence of valley incision, and sharp decrease of relief, etc. The area is dominated by extensive floodplains, over which a few major streams meander broadly and slowly. By the end of old stage, the whole surface approaches closer to the base level. It was called peneplain by Davis. At the end, a few hard and resistant rocks hillocks are seen and are called monadnocks. It was named after Mount Monadnock in New Hampshire, USA. When a cycle of erosion is going on and the same landmass is uplifted before the completion of the cycle, it is termed as rejuvenation. The vision cycle of erosion is based on the concept of understanding landscape development in evolutionary terms. Successive three stages such as youth, mature and old could appear in many areas in the nature. However, there are some imperfections observed in his assumptions. They raised doubts about his conclusions by the scientific community. For example, most interfluves appear to grow narrower with parallel retreat of valley slopes. But Davis described interfluves and said that they are reduced in height as the cycle advances. A more important difficulty with the vision model is that the land upliftment does not take place until the cycle is completed. Another example, the peneplain surfaces are recognized in some areas but not everywhere. 4.3.2 Penck model. Walter Penck, German geomorphologist, objected the division cycle of erosion. According to him, the landscape characterized in a specified area is related to the tectonic activities of that region. According to Penck, landforms are an expression of the phase and rate of landscape upliftment in relation to rate of erosion, where both upliftment and erosion may be a continuous process. According to the Visan model, erosional process starts when the landscape is completely uplifted. The landmass is eroded to a featureless low-relief landscape. Penck agreed with the concept of the vision eroded landforms of low relief, but he opposed the rapid upliftment and repeated cycle of erosion. According to Penck, upliftment of the land and denudation process starts at the same time. He used the term entwicklung, meaning thereby development in the place of stage. For the youth, maturity, and old stages he proposed the terms of staged entwicklung, waxing, or accelerated rate of development, gleichförmig entwicklung, uniform rate of development, and abstaged entwicklung, waning or decelerating rate of development. Fig. 4.7 explains three basic phases of landscape development as proposed by Penck. Look at the screen. Fig. 4.7 Penck's concept of the landscape development. In the first phase of development, land surface rises slowly and reaches to the summit level at maximum. The landscape development begins with the upliftment of primarum, initial landscape with low height and relief, representing an initial featureless broad land surface. In this stage, rate of upliftment is high, but the absolute height is low. effect of erosion is relatively less. With passage of time, it is accelerated. Since the upliftment of landmass exceeds the valley deepening, the absolute height goes on increasing. When upliftment rate exceeds the denudation, the convex slopes are formed resulting from waxing or accelerated rate of development. It is called, in German, aufsteigende Entwicklung. Second phase is uniform development of the landscape. Upliftment and denudation match with each other. It forms uniform straight slopes with passage of time. It is called, in German, gleichförmige Entwicklung. Initially, it is characterized by continuation of accelerated rate of upliftment and but attains the same rate of erosion. Hence, the relative relief remains constant. In a subsequent subphase, the upliftment is slower with similar rate of erosion. In this case as well, the relief remains the same. At the end of this second phase, upliftment of the land stops completely. Altitudes of summit divides start decreasing and relative relief remains constant. Because of the rate of lowering of divide summits, which equals the rate of valley deepening, the final phase of landforms development leads to waning development, termed as abständige Entwicklung in German. The erosional process is dominant, and both absolute and relative relief show declining trend. In this final phase of landscape development, upliftment is absent and valley deepening slows down due to reduced altitude and slope. The valley side slopes of upper part have steep slopes called gravity slopes, while the lower part is called wash slope, which consists of low inclined talus material. Further, ridges of the summit divides are reduced to steep-sided conical residuals. Their height gets further and small hillocks called Inselbergs. This Inselberg landscape is observed by a series of concave wash slopes termed as Endrump, feature formed at the end of cycle of erosion. 4.4 Conclusion. So far in this unit, you have studied thoroughly and understood the following key points. As you know, land surfaces are constantly undergoing modifications through endogenetic and exogenetic forces. You came to know that exogenetic forces originate on or above the Earth surface. They are mainly weathering, mass wasting, and different types of erosional processes. You have learnt about two important concepts of landform development explained by Davis and Peng. The sequential development of landscape was initially proposed by Davis. It explains in three stages, namely young, mature and old. Peng's view on the cycle of erosion is based on parallel retreat of slope. According to him, it operates with emergence of landmass as well as erosion simultaneously. In nutshell, you have studied the processes related to weathering, mass wasting, and the cycle of erosion. This information will definitely help you to understand the processes carried out by various geomorphic agents in the landform development. You will learn elaborately the processes of running water, groundwater, glacier in Unit 5 and wind, sea waves in Unit 6 of this block. Keep learning. Thank you.